Hey guys, welcome back in the Multicast video series. So, in this video section, I'm going to talk about source specific multicast. Before proceeding to the next section, I will like to recap what we have learned so far. So far, we have learned about PIM sparse mode, which is very much dependent with the RP. And in the PIM sparse mode, the receiver is not aware of the sender, so that's the design challenge which is addressed by source specific multicast. And basically RP is the common point where sender and receiver meets. So basically from the source to RP, the S comma G a tree is built, and from receiver to RP star comma G, which is a shared tree, is built. So in this section, in the case of once application sends data to the RP, so out of multiple RP, there is a uh, election happen which router or which device will serve as a RP. So in that case, PIM designated routers here's about the applications feed, which is S comma G, and that designated router will send unique PIM register message to RP. And once RP acknowledges with register stop message to PIM designated router, and after that RP knows about the source. So RP knows about the S comma G entry. Now going to the next slide, and we will understand the perspective from the receiver side. So basically, it will send IGMP version 1 or maybe version 2 report packet with star comma G entry towards RP. So possibly IGMP, then IGMP courier converts into PIM join, and it will send it towards the RP. And once it will send to RP, before sending, definitely there will be reverse path check uh, will be done, and once it is passed, it the join message will be sent towards the RP. Now RP is now aware of the receiver as well now. So as soon as RP joins the S comma G table, it sends S comma G join towards the source. So which means RP will send join towards the source, and as soon as source receives the join from the RP, the data or the traffic flow data or the traffic started flowing from the source towards RP. Now the RP forwards the traffic to the receiver with star comma G, which is with the shared tree. And now we will talk about the SPT handover, which is nothing but shortest path tree handover. So in this case, like last hope router sends a PIM join with S comma G, and also a last hope router will send PIM prune message. So basically, it is a shifting from shared tree towards a shortest tree. That phenomena is called or defines as SPT handover. And after the SPT handover, receiver is now joined to S comma G table. So suppose if we are not using source specific multicast, and previously we were using PIM sparse mode, which is pretty much dependent on the RP. So there are a couple of design issue which we are going to discuss it in this slide. So basically, the receiver is not aware of the sender in advance, and even the RP is acting as a bottleneck in the control plane. So in that case, if RP is failed, then new tree cannot be built, and new data cannot be forwarded to the receiver. And but this will not affect the existing group, because in that case SPT switchover or the handover is already done. So for the existing group, even if the RP fails, the data will continue to flow. So and to mitigate this problem, the solution will be we need to configure or we need to use source specific multicast. So which we are going to discuss it in the next slide. So basically, source specific multicast, it uses group ranges from 232.0.0.0 with a subnet mask of 8. And in that, after using this source specific multicast, receiver will know about the sender in advance, and it also uses IGMP version 3 to report to the signal for S comma G join. And once the receiver is aware of the sender by advance, which means it is not dependent on the RP. So even if RP fails, data is even for the new group, data is continue to flow. So and even the last hope router, in this case, last hope router sends S comma G and pim join towards the source. And in this case, star comma G tree is not built, and it is only dependent on SPT tree, which is like nothing but shortest path tree. And I'll show you in the lab demo how you can configure source specific multicast, and what are the challenges we are going to face, and what are the advantages of configuring source specific multicast.